Hi everybody, for this video we're going to talk about combining functions. You guys should already be familiar with the different ways to combine functions, so we're going to review some of the notation, and then we're really going to focus on domain and range of combined functions, which maybe you haven't seen before. Okay, so first we're going to talk about the arithmetic ways to combine functions. Okay. So remember that means plus, minus, times, and divide. Okay, and let's just review the notation. Okay, so if you have f plus g of x, okay, you define that to be f of x plus g of x. Similarly, if you have f minus g of x, this is f of x minus g of x. Okay. If you have f times g of x, this is f of x times g of x. Okay, so for this one, it's actually super important that you use the notation correctly. You can't put any type of multiplication symbol between them, and you also can't put like double parentheses or anything like that, because that would mean something else completely. Okay, so make sure that when you're doing multiplication, you have it like this, where they're just written next to one another. Okay, and then for division, we just write them as a fraction. Okay. All right, so let's talk about the domain. Okay, so the domain for the first three of these functions, right, or combinations, I guess, is going to be the same. Okay, so for those three, okay, the domain okay, is anything that's in the domain of both f and g. Okay, because you're plugging it into both functions here, like you can imagine how you would plug something into one of these, right? Because you have to plug it into both f and g. That means that the domain has to be things that can be plugged into both f and g. Okay, now for the last one, okay, f over g, okay, you start the same way. Okay, so we start the same way, any x that's in the domain of f and g, okay? And then you also have the restriction, okay, that you don't want the denominator to be 0. Okay, so start the same way, anything that can be plugged into both f and g, and then because it's a fraction, you don't want the denominator to be 0 there. Okay, so you don't want to plug in any x that's going to make your denominator 0. Okay, so let's do an example. Okay, so the first thing we're going to do is find the domain of each function individually. Okay? So because these are just lines, right, you don't have any restrictions on what you're allowed to plug in here. Okay, so we would say that for both f and g, okay, the domain is everything. Okay, and you can write that as an interval like that. Okay, so now let's look at part B. Okay, so we're going to find the first three, f plus g, f minus g, and f times g, and then we're going to find the domains for each function. Okay, so f plus g of x is f of x plus g of x. Okay, so we're going to take our two functions and add them together. So x plus 3 plus 4x minus 1. Okay, and always with these problems, you're going to simplify them down as much as possible. So we're going to combine like terms here. Okay. So x plus 4x is 5x, and 3 minus 1 is 2. Okay, so that would be our final function f plus g of x. Okay. Now, the domain, remember, is anything that's in the domain of both f and g. Well, f and g both contain everything in their domain, okay, so we would have for this, so that the domain is going to be negative infinity to positive infinity, right? There's nothing excluded from the domain of either of these, so that means for their combination, there's still nothing excluded. Okay, so let's do f minus g. Okay. Okay, we're just subtracting the two functions. So f minus g of x, and then we're going to subtract. So x minus 4x is negative 3x. Okay, and then 3 minus negative 1 is 4. Okay, and again, the domain is going to be everything. Okay, so last one of these for part B. F times g of x, this is f of x times g of x. Okay, and we're going to multiply these together. Oops. Okay, so remember, when you're doing these combinations, you're always going to simplify it as much as possible, which means we're going to multiply this out. Okay, so we would get 12x minus 1x, which is 11x, and 3 times negative 1 is negative 3. Okay, and again, our domain is the same as the first two, it's everything. Okay, all right, so let's look at part C of this example. Okay, so we're going to find f over g and its domain. Okay, so we would have f over g of x is f of x over g of x, okay, which is x plus 3 over 4x minus 1. Okay, now there's no restrictions coming from plugging into either one of these separately, okay, and remember the domain for the fraction, right, you don't want to have 0 in the denominator, okay, so what that means is you don't want x to be equal to 1/4, okay, because that would make this 0 in the denominator. If you write this as a interval, It would be negative infinity to 1/4 union 1/4 to infinity. Okay. All right. Let's do a little harder example like this. Okay. Oops. So the first thing we're going to do for part A is just find the domain of each of these separately. Okay. Now, for each of these, we have a square root. So remember that you want the radicand, or the stuff inside the square root, to be greater than 0. Okay, so for f, okay, that would mean that we want x plus 2 to be greater than or equal to 0. Okay, and that means that we want x to be greater than or equal to -2. Okay, so that's going to give us our domain being -2 to infinity. All right, so let's look at g. Okay, now we want x squared minus 4 to be greater than or equal to 0. Okay, now I'm going to remind you that this is the kind of stuff that we did in S.15, where we were talking about polynomial inequalities. Okay, so just because this is in a different context doesn't mean that you would solve this any differently. Okay, so you would still factor, okay, and you would still make a sign chart. Okay, so that would have -2 and +2. Okay, and then my two factors on the side. Okay, so you want things greater than or equal to 0, so this is going to be negative infinity to -2, okay, and 2 to infinity. Okay, all right, so let's look at part B. Okay, so we're going to find f times g of x and its domain. Okay, so f times g of x is f of x times g of x, okay, which for this example is x plus 2, square root of x plus 2 times square root of x squared minus 4. Okay, so you can simplify this. Okay. All right. Okay, and that would be my simplified f times g. Okay, now let's think about the domain. Okay, so we have things that are, we want only things that are both in the domain of f and in the domain of g. Okay, so what we're going to do is look at the number line. Okay, and we're going to graph the domain of f and the domain of g. Okay, so for f, okay, remember from part A that the domain was everything greater than or equal to -2. Okay, so I'm going to start at -2, and I'm going to go greater than that. Okay, then for g, remember we had up to -2 and then greater than +2. Okay, so we're going to mark those. Okay, so we would have up to -2. Okay, and then we would have, oh, you can't really see the lines anymore. Okay, then we would have greater than +2. Okay. So we're looking for where those things overlap. So you can clearly see that they overlap here, right? That's what we mean by in both domains, is the places where the domains overlap. So that's going to be here, so from 2 to infinity, okay? And also this single point right here at -2, okay? All right, so the single point at -2, and then the interval between +2 and infinity. All right, let's look at part C of this example. Okay, so now we're going to do f over g. So f over g of x is f of x over g of x, okay, which is going to be square root of x plus 2 over square root of x squared minus 4. Okay, and again, like we said before, with these problems, you're always going to simplify it as much as possible. Okay, so I'm going to turn this into one big square root. Okay, and then I'm going to try to cancel this common factor. Okay, last step. Okay, cancel the x plus 2's, and I just have 1 over x minus 2. Okay, which you could rewrite like this. Okay, all right. So a little bit of radical simplifying there. Okay, so let's think about the domain. Okay, so remember, the domain doesn't really depend on what it simplifies to. The domain depends on the original two functions. Okay, so the things that we're starting with, okay, are things that are in the domain of both functions. Okay, so remember that was 2, and it was an interval 2 to infinity. Okay, now the only thing we're going to leave out of that or change about that is we don't want something that makes 0 in the denominator. Okay, so think about g of x. Okay, and we don't want this to be 0. Okay, so if we set it equal to 0, we'll be able to see when that happens. Okay, square both sides. Factor, or use a square root, I guess. Might be easier. Okay, so we're going to exclude from the previous domain any values that we find here. Okay, so we're going to exclude plus and minus 2. So if you look at what we were starting with, that included both 2, oh, I'm sorry, this is supposed to be -2, both -2 and +2. So we're going to exclude those. Okay, so we're going to get rid of the -2. No. Okay, and we're going to exclude this also, and we do that in the interval by using the parentheses. Okay, like that. So that would be our domain. Okay, it is not based on the simplified function. Okay, it's based on the original functions here. Okay. All right. So now that we've talked about arithmetic composite, or combining of functions. Let's talk about composition. Okay, now you guys should have seen composition of functions before. Okay, so this is just a review of how it works. So remember, composition means first one function, then the other. Okay, so let's look at the notation. Okay, so the more popular notation looks like this. Okay, and you would read this as f composed with g of x. Okay, so that's how you would say that out loud. Okay, there's another notation for this. Okay, that looks like that. And people usually say this f of g of x. Okay, but you could also say f composed with g for this notation. Okay, that phrase would make sense for either one, but it's more common to read this as f composed with g, and this is f of g of x. Okay, all right. So let's do an example that kind of gets to the meaning of this. Okay. So here's our table of values for f and g. Okay. And we're going to find some compositions. Okay. Okay. So we talked about first one and then the other. Okay. So which one do you plug into first? It's the closer one. Okay. So you would find g of 0. Okay. So we're going to use the table. So if x is 0, g of x is 1. Okay. And then you're plugging your solution into f. Okay. So if x is 1, f of x is 0. Okay. So that would give us our final answer, f composed with g of 0 equals 0. Okay. Let's do part B. We're going to use the same table. Okay. So again, you're going to plug into the closer one first. So we're going to find f of 1. Okay, so if we look at our table of values, at 1, f of x is 0. Okay. Then we're going to take our solution. Okay. And we're going to plug it in. Okay. So if x is 0, f of x is 2. Okay, so we would have g composed with f of 1 equals 2. Okay, and that's how you should format your final answer. Okay, all right. So let's look at if we don't have a table of values, but instead we have some equations. Okay, so here's our equations. All right, so for part A, we're going to find f composed with g of x. Okay, and then for part B, we'll find g composed with f. Okay, so if we have f composed with g, that means you would plug something into G, and then you would plug that answer into F. Because we're not plugging in a specific value, we're plugging in everything from G. So we're going to take the whole function G, and we're going to plug it into f of x. Okay, so we're taking the function f of x, which is 2x minus 3, and we're plugging in the function g of x. Okay. And then we're just going to simplify this. Okay, so that would be our final combined function. All right, so let's find g composed with f. Okay, so this is going to be taking our function g of x, which is x squared minus 1, and we're going to plug in f of x, the function. So we'll put in 2x minus 3. Okay, now we have to square this function, so that's going to give us 4x squared minus 12x plus 9. Okay, and then I still have my minus 1. So this is going to give me 4x squared minus 12x plus 8. Okay, so as you can see from this example, okay, it does matter which order you compose them. F and G are different functions, so the ordering will actually matter. Okay, you can see that F composed with G and G composed with F, totally different answers. Okay, all right, so let's talk about the domain of this. Okay. Okay, so to find the domain, you just kind of think about what would happen when you plug in an x value. Okay, so the first thing that would happen is you would plug in that x value to G. Okay, that means we have to be able to plug in the value of G. So x is in the domain of G of x. Okay, meaning we're allowed to do that first step and plug that value into G. Okay, then we would get our answer, and we'd plug the answer into f of x. Okay, so what that means is we need to be able to plug that answer into f of x. Okay, so we have an additional condition that g of x is in the domain of f. Okay, so whatever that value is, right, you should get your answer, and you should be able to plug that answer into the second function, f. Okay, so let's see an example. Okay, so we're going to find f composed with g first. Okay, so f composed with g of x, okay, is going to be the function f, which is the square root function. Okay, and we're going to plug x plus 2 in there. Okay, so there's nothing really to simplify here, so this would be our function. Okay, so for part B, we're going to find the domain. Okay, now we're going to follow the two steps. So the first thing we want is to be able to plug the into the function g of x. Well, that doesn't create any restrictions because you're allowed to plug anything into g of x. Okay, then the second thing is you want to be able to plug your answer into f of x. Okay, so we want our answer, which would be x plus 2. Okay, Well, what are you restricting with the square root function? You want it to be greater than or equal to 0, so we will say, oh, we want this to be greater than or equal to 0. Okay, so our final domain would be -2 to infinity. Okay, no restrictions from plugging into g of x, but we do want that answer that we get from g of x to be able to be square rooted, meaning we need it to be a positive value. Okay, so let's do a different type of example with composition. All right. Okay. So what we're looking for here is two functions that would lead to this composition, okay? So remember, f is going to be like the outside function, right? The one that you do second, and g of x is going to be the inside function, or the one that you would do first, okay? So if you look at this, there's two operations going on. You have the +1 operation, and you have the square operation. So those are going to be our f and g, okay? And remember, g comes first. So we would say that g of x is going to be the +1 operation, so x plus 1, okay? And then f of x is going to be our second operation, which is the square operation, right? So x squared. All right, let's look at another one of these. Okay, so again, we have two operations. We have -3 is one operation, and then square root is the other operation. Okay, so g is the one that goes first, so that would be the -3 operation. Okay, so x minus 3. Okay, and then the second operation is the square root, so f must be the square root function. Okay, let's do one more like this. Okay, so if you think about plugging in a number for x, the first thing that's going to happen to it is it's squared. Okay, so that means our first function, g of x, is the square function. Okay, and then what's going to happen to it second? Well, you're going to divide 1 by that number. So that operation is you're going to divide 1 by that number. Okay, so first you would square, then you would do 1 divided by. So first you square, and then you do 1 divided by. Okay, all right. So I hope this reminds you guys of composition and sheds a little bit of light on the domain, and I'll see you guys